Tsunami is a natural hazard that poses a threat to Western Australia's marine and land environments. To learn about tsunamis, we drew on the expertise of Geoscience Australia, who has a key role in the tsunami warning process and research, as well as vital partnerships with the Department of Fire and Emergency Services and the Bureau of Meteorology. We then spoke to experts from these two key agencies, as well as the University of Western Australia.
The definition of a tsunami is a movement or a wave which is generated by a sudden impulse. And that impulse could come from an earthquake, from a thunderstorm, from an asteroid hit, or an underwater landslide. Most of the earthquakes comes from Indonesia. So the area which is most vulnerable for Western Australia would be the northern coast, so the Kimberley and the Pilbara. Particularly off Northwest Cape, where we have the narrowest part of the continental shelf, so off Ningaloo, for example. Then when we come further south, north of Geraldton is also susceptible because we actually have the Wallaby Plateau, which moves offshore, and that has the effect of deflecting any waves towards north of Geraldton. So we do have an effect to the south of Geraldton, but it's minimized, but the most susceptible would be to the north. On the other hand, if we're talking about meteorological tsunami, anywhere from Geraldton to Esperance, we have quite a number of occurrences per year.
Tsunamis are usually caused by large earthquakes of at least a magnitude 6.5, and that causes the ocean floor to flip up, and the entire depth of water above the earthquake causes a rapid shifting of that water, and waves will be generated above that point. Now, these waves are really quite different than sea and swell waves that people are most familiar with. They have a vast amount of energy. They have a very long wavelength of around a couple of 100 kilometres between peaks, and they move extremely fast across deep ocean waters, around the speed of a jumbo jet, around 900 kilometres per hour. Now, as those waves come in towards the coast, where the water gets shallower, a couple of things happen. The waves slow down, but they also increase in height. And so what happens is all that energy which has been contained right across the deep ocean is then transferred onto the coast. That accounts for about 80% of most tsunamis. The other 20% are caused by things like volcanic eruption or undersea landslides, or even meteorite impacts. Tsunami events that affect the West Australian coast are relatively infrequent. They occur roughly every year or two, and generally the tsunami warnings that we get in Western Australia are of the marine threat variety. But having said that, there have been a number of fairly significant impacts over the past 30 years. In 1977, up on the northwest coast at Dampier, there was some land inundation. In 1994, on the western side of Northwest Cape, there was evidence of rocks and fish carried at least 300 metres inland. In addition to that, in 2006, a tsunami caused the destruction of a campsite at Steep Point on the upper west coast, and evidence there was that the wave carried at least 200 metres inland. In 2004, the Indian Ocean tsunami on Boxing Day that people will no doubt be aware of, there were quite significant impacts in Western Australia. 30 to 40 people had to be rescued from the sandbar to Penguin Island, and there were numerous reports of marine craft, boats damaged in marinas sort of up and down the coast. This is actually the Indian Ocean tsunami event of 2004, where the earthquake was actually centred on the northern side of Sumatra, so most of the energy was pushed out across the Indian Ocean and westwards. If an earthquake of similar magnitude occurred further east to the south of Java, then the energy is likely to be directed more directly to the northwest Australian coast, and the response time would be less, of the order of 3 to 4 hours. However, it's not quite as simple as that. The bathymetry, or the depth of the ocean, plays a considerable role, and the tsunamis are sort of channeled by the bathymetry, and in fact a lot of the places further south down the west coast can be more at risk than say the Kimberley coast, for example, as a result of the bathymetry.
In the Northwest Shelf, it's a sort of an interesting area. Because the Northwest, we have quite a wide continental shelf. So when we have a wide continental shelf, a lot of the tsunami loses its energy as it comes along. So, and also the Northwest Shelf has a large tidal range. And also it's an area which is susceptible to cyclones. So when you look at cyclones and storm surge and tsunamis, they're sort of inverse. So when you have a wide continental shelf, you get a bigger storm surge and a lower tsunami because of the system. So in the Northwest Shelf, if we are prepared for tropical cyclones, we would be normally prepared for tsunamis. Now, if you have a 10-meter tidal range, and if you had even a 10-meter tsunami which occurs at low tide, you will not see any effect on the coast. But of course, if it happens at high tide, it would have quite a large effect. So the timing of the tsunami in terms of the state of the tide is important in terms of what the ultimate effect would be in the system.
The Bureau of Meteorology and Geoscience Australia together operate the Joint Australian Tsunami Warning Centre. The centre operates 24/7, 365 days of the year, and its job is to provide warning information to the Australian citizens. The role within that centre of Geoscience Australia is essentially they're the expert on earthquake detection and magnitude. And the role of the Bureau of Meteorology is to firstly model the tsunami situation, so that's determining which sections of the coast are likely to be impacted, what time the waves will arrive and what size they will be. Once we've run that information, we analyse it and then make an assessment on what the impact on the coast is going to be from a public warning perspective.
The main effect of a tsunami is flooding in terms of the water coming ashore. The water has a lot of force in it. If you think that 1 cubic meter of water is 1 ton. So there's a lot of heavy momentum which basically can take. So people can wash away, the houses, etc. And so the biggest danger is the impact in terms of flooding. And particularly if you're offshore, you don't have that much of an effect. It's basically a coastal effect. And you probably know the name of the tsunami means harbor wave in Japanese. And the name for that is derived because the biggest impact or the effects you see in harbors, in enclosed areas. So in terms of, although you may not have flooding, in coastal areas you would have strong currents and a lot of agitation within harbors, etc.
The warning system in place for tsunami in Western Australia is a two-tiered warning system. There's the marine threat level warnings, which essentially mean that we're expecting strong currents, dangerous rips and strong waves in the marine environment, so the ocean and the near coastal environment. People are advised whether they're swimming to get out of the water and get away from the immediate foreshore, because sometimes the effects can not just be confined to the coast, it can spill over to the near coast. So that's the marine threat warnings. In addition to all of those impacts, in a land threat advice, we get those marine impacts, plus there's the potential for inundation across the land, and the advice to people there is to move at least 1 kilometre inland or at least 10 metres in height. We advise the Department of Fire and Emergency Services about what we know about the tsunami, what are the possible scenarios, so that the department can then enact their plans and inform the community.
As a hazard management agency, DFIRS in Western Australia has a responsibility for prevention, for preparation, for response and recovery right across the board. In relation to tsunami, the key aspects, of course, is that we've got to have planning in place. That has to be done across the community. Works very much from state level right down through to local level to ensure that there's suitable arrangements in place in case we are impacted by a tsunami. But most importantly, we've got to make sure that we've got an aware community out there as well that knows what to do in the event that a tsunami does happen. So having warned communities, it's likely that there will be evacuations occurring. So communities need to have in place evacuation arrangements. And again, those exist quite often related to other hazards. So we're able to dovetail into these other arrangements. So the warning is the most critical part of the response. There's two parts to it, and that is to actually let the public know what they need to be doing and to keep that information flowing. But secondly, to make sure that the responding agencies are actually informed in a timely way so that they can activate their plans. The sort of actions that come from that is so that people can actually go to the coastline, go to beaches, to clear beaches, to move people out of the way, particularly if there's a land inundation threat that's been forecast. Other possible actions can include notifying ships, people at sea, so that they know what actions to take to actually move out further to see if they're already in deep water. If people are actually in harbours, to secure their vessels and then move away from the coastline. Our biggest challenge always is the very short time frame, and that time varies depending where you are in Western Australia, depending where the earthquake actually originated. Key agencies that we work with in Western Australia start with police as the emergency coordinators. Western Australia has a very broad coastline, of course, so we have a number of agencies that have key roles related to the coastline and working directly with the community. They can involve agencies like the Department of Transport, people that manage harbours, child protection, family support, to assist in the event of evacuations, and of course local government and local groups such as Surf Lifesaving.
Tsunamis in Western Australia are a pretty rare event in terms of significant impact, but people need to be aware it's possible and be prepared that in a worst case scenario there could be a significant impact on parts of WA, and people do need to be prepared.